Example 1, you want to see if 3 different golf clubs yield different distance traveled by ball strike on an automated driving machine. You randomly select 5 measures from trial on an automated driving machine for each club. At the 5% significance level, is there a difference in the mean distance? So when you're looking at the question, you need to ask 2 questions, just like before. You need to know which situation you're in, and you need to know which testing are you dealing with. So how we know which situation we're in is we look at the data. In the data, we know that we're given 3 samples. So we have 2 or more sample size because we have club 1, club 2, and club 3. And when we look at the data set, we know these are numbers. So we know, therefore, these are numerical variables. So that's why we have 2 plus sample, and then we have numerical variable. So that's why we know this is chapter 11. This is ANOVA. Once we know which situation we're in, then we need to know which testing are we dealing with. And how we know which testing we're dealing with is we look for the keyword difference. Difference means that we're dealing with 2 tails. So we have 2 tail hypothesis testings. So part A, when we state the null hypothesis and the alternative hypothesis, we copy what we have from the lecture notes. So again, for H null, what we have is mu1 equals to mu2 equals to mu3 all the way to mu c. H1 is that not all the mean are equal. So that's what we put down for our hypothesis testings. So for H null, we have mu1 equals to mu2 equals to mu3. That's our original situation. Originally, we have to assume that the mean distance traveled by all 3 clubs are the same. That's our original situation. That's H null. And for H1, H1 is what we want to prove. We want to prove that not all the mean are the same. So once we have H null and H1, then we can move on to part B. Part B use test statistics as decision rules. So this is the ANOVA table generated from Excel. I'll show you how to get this table from Excel right now. Right now, I'll show you how to run the ANOVA analysis in Excel. In this question here, what we have is given is the 3 clubs and the data here. We have the data sets here. And what we're going to do is we're going to follow the steps here, and I'll show you how to run the ANOVA analysis. So what we're going to do is we're going to click on File, Options, Add In, and then we're going to press Go, and then we're going to check off Analysis Toolpack. So our first step is to enable the data analysis in Excel, and we're going to do that right now. So File, Option, Add In, Go, and then check off Analysis Toolpack. So we're going to click on File, Options, and then we're going to click on Add-ins, and then we're going to press on Go. So bottom middle, and then we're going to check off Analysis Toolpack. So make sure the Analysis Toolpack is checked off. Once this is checked off, then we press OK. And then what you will see is that under the Data tab, what we have is Data Analysis. We're going to use Data Analysis. And then what we're going to choose is we're going to choose the first one. We're going to choose ANOVA Single Factor. So we're going to go to the very top, ANOVA Single Factor. We're going to select ANOVA Single Factor, and then we press OK. And then what we're going to do is we're going to highlight the data. We're going to highlight C6 to E11. So we highlight C6 to E11. And then what we're going to do is we're going to check off label in the first row. We're going to check that off. The reason we check off the label in the first row is because when we highlight the data, we included the heading. The heading is your club 1, club 2, and club 3 because we selected from C6 all the way to E11. So we included the heading. So that's why we're checking off the label in the first row. And then our alpha is 5%. So once we have done that, we press OK, and then Excel will generate the ANOVA analysis table here for us. So a couple of things that you need to know from here. So the first thing is F. F represent your F statistics, and then we have the F critical. So right at the beginning, we have the F statistics and we have the F critical. Then we can make our conclusion already. So we know that F statistics is greater than F critical, so therefore we know that we can reject H null, and then we can accept H1. So that's the first thing that you need to know. You need to know where to get the key variable, and then you need to know what to compare. Right? So we have the F statistics, and then we have the F critical. We can compare them, and then we can make the conclusion. We know that statistics is greater than critical, then we can reject H null, and then we can accept H1. The second thing that you need to know is that sometimes the p-value are given to you in a weird notation. So this is a scientific notation. And what we need to do is we need to convert this to a number that we can actually understand. And how we do that is we can right-click on it. Right-click, and then we can click on Format Cells. Once we click on Format Cells, we're going to click on Number, the second one, Number. And then you will see that if you look at the decimals here, what we can see is that we're going to increase the number of decimals until we can see a number that we understand. So we put it to 11 decimal place in this example, and we'll see that what this number represent. And then we press OK, and then now we know what that number means. So make sure you note this trick, right-click, Format Cells, and then you click on Number, and then you just increase the number of decimals until you can see a number that you can understand, and then you press OK, and then Excel can convert that from a scientific notation to a regular number. The third thing that you need to know is some of the relationship here. For example, you have your SS, which is your sum of square. Sum of square divided by degree of freedom give you the mean square. Right? So if you take the 4700 divided by 2, you're going to get the 2300. Same for the within groups. If you take the sum of square, you divide it by degree of freedom, that will give you the mean square. So that's why you need to follow the formula sheet in the lecture note to look at the relationship between these variables. And this is the table that I'm referring to. You need to know the relationship between the sum of square and the mean square and the degree of freedom. And you need to know how the degree of freedom is calculated. C is your number of groups, N is your sample size. And then for your F statistics is calculated by dividing the two mean square. You take the MSA divided by MSW. So that's the third concept that you need to know. The fourth thing that you need to know is you need to know how to calculate the p-value and critical value. Sometimes in the question that you're dealing with, they're not going to give you the p-value and critical value. You need to know how to calculate that in Excel. And the formula for calculating p-value is f.this.rt. The formula for calculating f critical is f.inv.rt. So I'll show you the formula right now. So to calculate p-value, what we did was we used f.this.rt. And what it will ask you is it will ask you for three variables. The first variable is your F statistics, so the 25.27. That's what the first variable is for. Second variable is for the degree of freedom 1. Third variable is for degree of freedom 2. So degree of freedom 1 is your 2. That's your degree of freedom for between groups. Degree of freedom 2 is your 12. This is your degree of freedom for within groups. Once you plug that into Excel, you're going to get the p-value. Same for F critical. F critical is f.inv.rt. First variable is your alpha. Alpha is 5%. Second variable is your degree of freedom 1. And the third variable is your degree of freedom 2. So we put the 2 and then we put the 12. Those are the two degree of freedom. So the concept is the same. For p-value, you use .this because this is F distribution, so you use f.this.rt. For critical value, you use INV, and this is F distribution, so that's why we use f.inv.rt. So again, the four concepts that you need to know in here from this example is that F is your F statistics, so you can compare F statistics with the F critical. You know that statistics is greater than critical, so therefore you can reject each null, you can accept each one. And what we're accepting is that not all the mean are the same. So we don't know which one is different, but we know that they're not the same. That's the first concept. Second concept that you need to know is the relationship here. Sum of square divided by degree of freedom gives you the mean square. When you divide these two mean square, it will give you the F statistics. And how we get the degree of freedom 2 and degree of freedom 12, how we get those is that for the between group, how we get the 2 is that we have 3 minus 1. We have 3 groups minus 1 gives you the 2 here. And then for the 14, how we get the 14 is that we know that we have a sample size of 15 here. We have 15 numbers. So 3 clubs times 5 gives you the 15. So 15 trials, so 15 sample size. So 15 minus 1 gives you the 14. So 14 minus the 2 gives you the 12. So that's how we get the degree of freedom. The third concept that you need to know is that sometimes Excel will give you a scientific notation because of the decimals. So you need to know how to convert this in Excel to a real decimals. And how you do that is you right click and then you click on format cells and then you click on numbers and then you increase the number of decimals. The fourth concept is you need to know how to calculate the p-value and critical value using the f.this.rt and the f.inv. So those are the four concepts that you need to know from this example.